Hi viewers, welcome to the yet another session of Smart Materials. Today we are going to see about biodegradable polymers. I am Dr. S. Rekha, Associate Professor, RMK Engineering College, Chennai. Let us get into the topic. So we are going to see today about biodegradable polymers, synthesis, properties, degradation scheme, uses, etc. Biodegradable polymers degrade. Every polymer which is existing will degrade biodegradably. Naturally, they will degrade. But the time period of degradation varies. It takes 100 to 1000 years. If it takes more than 100 years, then we call it as non-biodegradable polymers. Biodegradable polymers takes less time to degrade. Okay. So this biodegradation can take place enzymatic degradation or spontaneous degradation, okay, depending upon the natural environment, either by the action of enzymes or either by the action of water, right? So biodegradable polymer degrade quickly. That is the most important thing. So it may take 500 years, but if a polymer takes less than 100 years, then it degrades very quickly, and it should produce an eco-friendly byproduct such as carbon dioxide, water, methane, and other organic biomasses present in it scavenged by a microorganism, right? So what are the microorganisms which can scavenge over this polymer are bacteria, fungi, algae. More important than definition of biodegradable polymer, what are the implications of biodegradable polymer, right? So when I prepare a biodegradable polymer, what are the things I am going to compromise? Okay, molecular weight decreases. I am reducing the molecular weight of a polymer. As you know, as the molecular weight of the polymer is decreased, many properties of the polymer is dependent on this molecular weight. So its property also get compromised. Second point, crystallinity of the polymer decreases. It get destroyed. And as I said, physical property like mechanical strength diminishes. Most of the physical property diminishes as the molecular weight is decreased. So we need to put compromise on this for biodegradable polymer. Then only, so it will find limited applications than the non-biodegradable polymer. But this is the one which is healthy, right, to the environment. So we have to go by this biodegradable polymer. In nearly all cases, biodegradable polymer will not degrade in landfill. Why? This is the most important question. Okay, biodegradation is mediated by either microorganism or bacteria, fungi, or the enzyme, right? Such process typically require water and oxygen, and we call such degradation as aerobic degradation, where we require water and oxygen. But when I put it in the landfill, deep landfill, so there is no water or air, so it has to undergo dry degradation, that is anaerobic degradation. Whatever polymer we have produced, biodegradable polymer, they are aerobic degradation. Only one exceptional polymer which we have is polyhydroxyalkanate called as PHA, which will degrade anaerobically. If you put it in landfill where you don't have oxygen, then biodegradable polymer also will not degrade as expected. Examples of natural biodegradable polymers are collagen, cystosin, gelatin, starch, albumin, wood, pectin, soya, etc. So many are there. Synthetic biodegradable polymer are polyglycolic acid, polyanhydride, polyesteramide, polyamide, polylactic acid, polyadipic acid, etc. Biodegradable steel. There are two schemes in which degradation occurs. The figure shown here makes it easier for you to understand how this degradation undergoes, right? So either it may undergo surface erosion or it may undergo bulk erosion, right? Surface erosion, see here in this figure. So it is full black is your polymer. Now only at the surfaces it starts degrading. Okay, not the bulk, it's surfaces. So for surfaces degrading, as the surface is degrading, as time goes on, see the size of the material is decreasing. So it takes long time to degrade because it is only surface degradation. Inner part of the material, until it is exposed, it is safe. It does not undergo degradation. I have another type of degradation called as bulk degradation, just like PLA undergoes. So all complete throughout the material degradation is applied. See, the black color is slowly decreasing in the figure and size remains the same. There is no decrease in the size. Finally, completely it degrades, right? So two types of degradation is there for biodegradable polymer. When I prepare a polymer, I can undergo either of the one method of degradation stream for degrading the polymer. Properties of this biodegradable polymer. Until degraded, biodegradable polymer retain their mechanical integrity, right? So as I make biodegradable polymer, already it does not have a much mechanical property, but one good thing is there, until it degrades, it retains whatever the mechanical property it has, mechanical strength it has, right? Since biodegradable polymer have extremely strong carbon bond, so it is difficult to break that bond or degrade that. So we start from N group. Generally, biodegradable polymer, we focus on degrading the N groups. These polymers are non-toxic in nature. Degradation rate of biodegradable polymer can be regulated. See, if I add more and more ionic group to the polymer chain, then it will degrade easily. Or if I make this polymer hydrophilic in nature, then it will degrade easily. If I want to degrade very quickly, accordingly I can manufacture. If I need some more time, in 50 years, in 75 years, in 100 years, what is the time period? Accordingly, I can manufacture the biodegradable polymer. So as we know, crystallinity is lacking in biodegradable polymer. More and more molecular weight increase or more and more crystallinity, biodegradable property declines. So crystallinity in this property decreases. Why? If crystallinity is there, we cannot prevent access to N group, right? That is, we are focusing on degrading this material at the N groups. But if they are crystalline, they will not degrade at the N groups. They are hydrophilic in nature. As I already said, they are hydrophilic in nature so that they easily undergo hydrolysis and degrade, right? Now classification, broad classifications of biodegradable polymer. So it is based on biomass product. It is based on microorganism from microorganism. It is based on biotechnology and it is from petrochemical product. So how do we synthesize? What is the starting material? Based on that, we have all this classification in that. Most important thing which we will be seeing in the next session will be PLA. Okay, so this is the most important biodegradable polymer. The benefits of biodegradable polymer. First thing is the amount of waste generated is reduced as they degrade easily. Reduction in carbon emission. It is found that biodegradable polymer on degradation produces less carbon dioxide. Reduced use of petroleum. Most of your polymer are prepared from petroleum products, and now this biodegradable polymers are made from natural material. So reduced use of petroleum, right? Greenhouse gas emissions are reduced. It is found that while degrading, this biodegradable polymer produce less greenhouse gas like methane gases compared to natural other polymer reduction, okay, biodegradation. They consume less energy during process as the process is easy and flexible. So the consumption of energy during the process is very less. It is easy to recycle biodegradable polymer. So they can be degraded, recycled very easily into a new article as the processing is easier. Factors that accelerate polymer degradation. More, if the backbone has more hydrophilic group, that is ionic group. Okay, more hydrophilic group as end group, more reactive hydrolytic group in the backbone, that is which can uh, dissolve in water. See, water solubility is the key for easy degradation. Okay, less crystallinity, more porosity, and smaller device size can easily degrade faster. Biodegradable polymer uses used in post-operative stitches. Medical products include tissue in growth material, controlled drug release system, plasma replacement in every places. That is, mostly it is highly biocompatible material. So it finds application in medicals. These are used in agricultural materials such as film and seed coatings. Why? Because it is biodegradable. These are used in fast food wrappers, personally hygiene product, etc. Used in and on the soil to improve aeration and promote plant growth and health. Right? Because of biodegradability, see how many different applications we are able to see. Used in drug delivery because it is essential for drug to be released slowly over time rather than at once, for the pills to stay safe in the bottle until it is time to take it. So drug delivery, so the capsules which we have, no, that is made up of the biodegradable material, and it is biocompatible also, it will not harm your tummy. Biodegradable polymer are used in gene therapy. Okay, this is also used as a therapeutic agent like anti-tumor, anti-psychotic, anti-inflammatory agent. Thank you, students. Let us meet you in another video on biodegradable polymer with as PLA as one of the example. Thank you. Thank you all.